Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about TreeMap. In this video I will speak about what is TreeMap, how it works internally, what problem it solves, what are the features of TreeMap, and what are the common methods that we can call on TreeMap. So if you are willing to learn TreeMap, make sure to watch this video till the end. So without wasting any time, let's get started. Alright guys, let's begin this video. So let's have a look at this map hierarchy diagram. So guys, if you look at this diagram, you will see that there are three general purpose classes that implements map interface. One is hashmap, second one is linked hashmap, and third one is TreeMap. In previous videos, we have learned about hashmap and linked hashmap in detail. So I highly recommend you to watch that video before proceeding to this video. Now in this video we are going to learn about TreeMap. Well, just to give you a context, let me recall once again what is map, what is hashmap, and what is linked hashmap. So guys, map is a linear data structure which is used to store key value pairs. And what is map interface? So map interface is an interface that defines all the essential methods to store and organize key value pairs. And this interface is implemented by hashmap and linked hashmap. Now next is hashmap. Now what is hashmap? So hashmap is an implementation of map interface. But here hashmap does not make any guarantee of maintaining the order of the key value pair. And hashmap also gives big O of one constant time to search, insert and delete operations. Now the next one is linked hashmap. So guys, linked hashmap is a class that extends hashmap. Okay, so all the features that are available in hashmap is also present in linked hashmap. But the really cool thing about linked hashmap is linked hashmap makes the guarantee of maintaining the order of all the elements or all the entries in the linked hashmap, and the order is maintained according to the insertion order of the entries. And linked hashmap also provide big of one constant time for search, delete and insert operations. Now here mind you that I am using entries here. So in context to map, we call key value pair as entries. So please remember this point. Now guys, if you closely look at the hashmap and linked hashmap, you will see one problem with hashmap and linked hashmap. So the first problem is we cannot sort all the entries of hashmap or linked hashmap according to natural ordering. Or for example, if we want to provide a custom ordering to all the entries, then so this is also not possible in hashmap and linked hashmap. So these are the two problems that we are facing in hashmap and linked hashmap. So guys, to solve this problem, here comes the TreeMap to our rescue. Now what is TreeMap? So TreeMap is a non-linear data structure which is used to store and organize key value pairs aka entries in a sorted order. Yes, you heard that right. Now you can store all the key value pairs or entries in a sorted order. So basically TreeMap is a general purpose class that implements map interface, and TreeMap makes a guarantee that by default all the entries of the map will be sorted according to natural ordering of its keys. So this means all the entries of the TreeMap will be sorted according to the natural ordering of its keys. So for example, let's say if keys are integers, then it will be sorted in ascending order. And for example, if keys are strings, then it will be sorted in alphabetical order. Now here comes the question that what about the custom ordering? Let's say we do not want to sort all the entries in natural order, then what is the solution? So in that case, TreeMap is very flexible. So it provides us two ways to sort all the entries. The first one is via comparable interface. So if you want to sort all the entries of TreeMap according to your sort order, then your key must implement comparable interface. And internally, TreeMap uses comparable interface to place entries before or after of each other. And the next method is if your key has not implemented comparable interface, then you are free to provide instance of comparator while creating the instance of TreeMap into the constructor of TreeMap. So these are the two ways you can provide your own sorting order to the entries of the TreeMap. So I hope this is clear to you that what is TreeMap and what problem it solves. Now this brings us to the next question, that why sorted map and navigable map sits between map interface and TreeMap class. So guys, if you look at this map hierarchy, you will see that there are two interfaces. One is sorted map and the second one is navigable map that sits between map interface and the TreeMap concrete class. And the TreeMap concrete class implements navigable map. Okay, so why is it so? Well, the reason is pretty simple. It is because of the separation of concern. So here the sorted map has some responsibility and navigable map has some responsibilities. So let me show you what are all the responsibilities. So here sorted map has two responsibilities. So the first one is sorted map interface is used to impose this restriction to all the keys of the map that it must implement comparable interface. But this was not the case in hashmap and linked hashmap. It was okay to store keys in hashmap and linked hashmap that doesn't implement comparable interface. But in sorted map implementation like TreeMap, it is compulsory that all the keys must implement comparable interface. So that TreeMap internally use compare to method to compare all the objects so that it can place object after or before as per the comparison. Okay, so this is the first responsibility. The second responsibility of sorted map interface is it defines all the methods that are specific to sorted map. Okay, so for example, there are 5 entries and all of these entries are sorted in natural ordering, then it will be easy for us to get the first key of the entry. Similarly, the last key of the entry. Okay, this would not be possible if TreeMap had not implemented sorted map interface. So these are the two methods to find the lowest key of the TreeMap and the highest key of the TreeMap. Other two methods are headmap and tailmap. So headmap is a method that takes 2 keys as the argument and finds a map of all the entries whose key is less than equal to the given key. And similarly, tailmap method takes from key as argument. So it's going to find map of all the entries whose key is greater than equal to the provided key. Okay. If these methods are not clear to you, then do not worry. We will see the practical demo of all this method in the next hands-on demo. Okay. Now moving on. So this was all about the sorted map interface. Now let's move on to the next interface, that is navigable map interface. So navigable map defines all the methods which is used to navigate to a specific key, right? So for example, there are 4 methods. These are most commonly used methods of navigable map. The first one is lower entry, and this method takes key as argument. So what it does, it finds an entry whose key is less than equal to the provided key. Similarly, higher entry method is used to find an entry whose key is greater than the provided key. The next method is floor entry. So floor entry takes key as argument and it is used to find key so that is greatest and less than equal to the provided key. Now the next method is ceiling entry. So ceiling entry takes key as argument and it is used to find list entry whose key is list and greater than equal to the provided key. Again, if these methods are not clear to you, we will see the practical demo of all these 3 methods in the next hands-on video. Now, if sorted map interface and navigable map interface is clear to you, let's move on to the next question, that is how actually TreeMap internally works. So in previous videos, we have seen hashmap and linked hashmap. So my question is it implemented using hash table, hashing or singly linked list or arrays, or is it implemented using hash table, hashing and doubly linked list? So guys, the answer is absolutely no. TreeMap is not implemented using hash table, hashing or arrays or singly linked list or doubly linked list. Then how is it actually implemented? Well, TreeMap is implemented using binary search tree. Yes, you heard that right. It is implemented using binary search tree, and more specifically, it is implemented using red-black trees. That is a variation of binary search tree, and these trees are balanced tree. Now, you might ask that what is binary search tree? So guys, I have already created a dedicated video on binary search tree. So I highly recommend to watch that video before proceeding to this video. But anyway, I will give a quick recap of what is binary search tree. So a tree is said to be a binary search tree if that tree satisfies these two properties. So the number one property is all nodes has at most 2 child, and the second property says starting from the root node, every node in the left branch of any node is smaller and every node in the right branch of that node is greater. So if you look at this binary search tree, on the left branch of 2 we have only 1 that is smaller than 2, and on the right branch of 2 you will see that there are 3, 4 and 5, and all of these elements are greater than 2. So that is why this tree is called a binary search tree. But guys, there is one major problem in binary search tree, and that is, let's say if I give you numbers like 1, 0, 2, 3, 4, 5, and if I tell you that follow these two properties and construct the binary tree. So if you construct the binary tree out of these elements, you will end up getting a right skewed tree. And what is right skewed tree? The tree in which the right branch is longer and the left branch is smaller. And that type of tree is called right skewed binary search tree. Now what is the problem with this skewed tree? Let's say we want to search 5 in this tree. So to find 5, first we have to traverse from the root node all the way to node 5. Okay, and it takes n steps to find the 5. So we can say that in worst case it takes big of n time to search any element, and this time complexity belongs to the class of linear order of growth, right? But that is not accepted because linear order of growth is way larger than constant order of growth, right? Because if you know from the previous videos, hash map and linked hash map provides constant time for searching, inserting and deleting, right? Similarly, if I give you numbers like this 5, 6, 4, 3, 2 and 1, and if you construct the binary search tree out of these elements, you will end up getting a right skewed binary search tree. And here you will see that left branch is longer and right branch is shorter. And now if you want to find 1 on this binary search tree, we have to start from the root node and go all the way to node 1. And to search a node, we have to take n steps, right? So we can say that in worst case, this tree also takes big of n time to search any element, and this is not accepted. So guys, this is the problem that is caused by normal binary search tree. So in order to solve these problems, red-black tree comes into picture. And the property of red-black tree is that it self-balances itself on all the insert delete operations. So for example, let's say we have numbers like 1, 0, 2, 3, 4, 5. And if we create a red-black tree out of all of these numbers, we end up getting a balanced binary search tree. Now you can see that this tree is perfectly balanced. So that is why red-black trees are called self-balancing binary search tree. And if you perform the search, get, put and remove operation, it takes big of h time in all the cases, in worst case, in best case and in average case. And what is h in binary search tree? H is nothing but it's a height of binary search tree. And how we compute the height of binary search tree? It's simply log of n, where n is the number of elements in the tree. So we can say that in all the cases, red-black tree takes big of log n time to search, get, put and remove operations. And this is what we want. Okay, so this is the main reason why TreeMap is implemented using a red-black trees instead of normal binary search tree. Because if it had implemented using normal binary search tree, then in worst case, it takes big of n time. Whereas in case of red-black tree, it takes big of log n time in all the cases. Okay, now I hope that it is clear to you that what is TreeMap, how it works and what problem it solves. Now let's see some of the features of TreeMap. So the number one feature of TreeMap is that it is implemented using red-black tree rather than hashing hash table. That is why it gives a guaranteed big of log n time for search, insert and delete operations. Okay. The second feature of TreeMap is in TreeMap entries are arranged in sorted order, right? And by default, TreeMap sort all the entries in natural ordering of its keys. Moving on to next feature, that is no null keys are allowed. Now guys, mind you that in hashmap and linked hashmap, at most one null key was allowed, but in TreeMap, null key is not at all allowed, right? So please make a note of this point, okay? Now the next feature is heterogeneous keys are not allowed, only homogeneous keys are allowed. So this means you can provide only one type of keys in TreeMap. But this was not the case in HashMap and linked HashMap. We can provide any type of keys in HashMap and linked HashMap. But why is it not allowed in TreeMap? Because TreeMap internally uses comparator to compare two objects so that it can order elements according to its sort order, right? That is why only homogeneous keys are allowed in TreeMap. Now the second feature of TreeMap is it is slower than HashMap and linked HashMap. And it is so obvious because HashMap and linked HashMap internally uses dynamic size arrays. And dynamic size arrays has random access support so that we can access any element in constant time. But as a TreeMap is implemented using red-black trees, the time of searching or traversing a tree is always big of log n, and we already know that big of log n is slower than big of 1. Okay, that is why it is slower than HashMap and linked HashMap. And the last feature of TreeMap is it implements map interface, sorted map interface, navigable map interface, serializable interface, and clonable interface. So these are all the features of TreeMap. Now this brings us to the next question, that how to choose which map to use. Well, let me show you some reasons which will help you to choose which map to use or not. Let's first consider the hash map. So in case you need fast search, insert and delete operations and you do not care about the order of entries, in those use cases you can simply use hash map. Now moving on to next map, that is linked hash map. So guys, when you want fast search, insert, delete operations but you care about the insertion of order of the entries, then in those use cases you can use linked hash map. Now what about TreeMap? So guys, when you want full control over how the keys should be sorted and you are ready to compromise with the access time of the element, so in that use cases you can use TreeMap, because TreeMap provides big of log n time complexity for search, insert and delete operations. Okay, so we could say that linked hash map solves the problem of sorting up to some extent without incurring the performance cost of TreeMap. So now I have shown you all the reasons when to use hash map, linked hash map and TreeMap. Now it's up to you and up to your use cases that which map algorithm fits best in your use case. So guys, by now I hope that you understood very well about what is TreeMap, how it internally works, what problem it solves, what are the features of TreeMap and what are the most common method that we can call on TreeMap. So this is all from my side guys. If you have learned something valuable, then hit the like button in order to make YouTube algorithm happy. Please subscribe to the channel and don't forget to click the bell icon so my friend you never miss any upcoming videos. Thanks for watching. See you in the next one.